All right, today I'm going to tell you about the dividing out technique in calculus. It's for taking limits. And what happens is the first thing we learn how to do is just a direct substitution. But what happens when I know my denominator is going to be 0? Well, ordinarily I would take the limit from the left and from the right and see if it goes, which way it goes to infinity. But here I have a different issue, if you want to call it that. So I have the issue of 0 plus, well, 0 squared plus 3 times 0, that's a 0, not a 6, all over 0. So I end up with 0 over 0. So what this is called is the indeterminate case. I'll write that down. Indeterminate case. Indeterminate. So what that tells me in calculus is there's something else I can do to this to simplify it and be able to evaluate it. So that something is, just like the technique says, dividing out. So I'm still going to take the limit as x approaches 0, but in the numerator I'm going to factor an x from that expression. And we notice that in the denominator I have another x. So these x's, x goes into itself once, and x goes into itself once. So that goes away. So now I can go to direct substitution and say, well, that would just be 0 plus 3, or 3. So the limit as x approaches 0 of this is 3. Now, the point 0, 3 is not on this function, okay? There's a gap in it. Sometimes they call it a removable discontinuity. So anytime you can divide out like this, you're going to end up with a graph that ordinarily would look like a regular graph, but it has a removable discontinuity. So this one, for instance, x plus 3, let me just get rid of this. So if I graphed x plus 3, let's see, it would cross 3 units up. So something like this. However, at 0, I would have a little gap in my, if you can see that, little hole in my graph. All right? So that is always what happens whenever you can divide something out. So I'll show you one more, and we don't need to look at the graphs, but I'll show you one more just for good measure that requires a little bit more factoring. So here's another case that's going to end up, I forgot my word form, end up resulting in an indeterminate form, 0 over 0. If I go to direct substitution, negative 3 times negative 3, well, that's 9, minus 3 is 6, and 6 minus 6 is 0. And then in our denominator, we have negative 3 plus 3. So that, if I tried to do direct substitution, is going to yield this indeterminate form of 0 over 0. So that means there's something else I can do. And that something that we're talking about today is the dividing out technique. So I'm still going to have the limit as x goes to negative 3. So as x approaches negative 3, I can factor this numerator into x plus 3 and x minus 2. So the cool thing there, notice that our x minus 3's will cancel out. So now I just have an x minus 2 left. Also, you can't end up with a 0 in the denominator, naturally. So I have 1 times x minus 2 over 1. So if I go to direct substitution here, I'm going to just stick a negative 3 in place of the x, which equals negative 5. So the limit of this expression as x approaches negative 3 ends up being negative 5. However, the point, negative 3, negative 5, again, this is not on the graph, right? It's a gap in the graph. So this negative 5, right? Negative 3, negative 5, that's not on the graph. Let me scooch and give us a graph here. So x Well, -2. So x minus 2 graphs kind of like this. But down here, where x is -5, there's a removable discontinuity. So this would be -3, -2, -1. So as I'm approaching -3 from the right and the left, I'm getting closer to that -5 value. So that's what this means. So eventually, we'll just be doing, in my calculus class, which I don't have this year, but people like calculus problems. So many more of these, all right? This is called analytic simplification, or analytically determining the limit of something. So hope you're doing good in school. It's been about 3 weeks for us, and everything's going so far so good. So hopefully everything's going good for you too. Don't forget, do your homework. All right, until the next time, this is Mr. Nolde signing out.